y with respect to x should be x squared y squared. So to do that, I'm going to differentiate my solution. I'm going to do it up here, d by dx. You don't have to do this every time, but I want to show you what it looks like at least this one time, in case you want to double check your work without using a calculator or some other means that we might talk about later. But for now, I want to show you how to do it the good old-fashioned way. So the derivative of y will be the derivative of negative 3 over x cubed minus 4. To find that derivative, I'm going to rewrite this slightly. I'm going to say the derivative of, it's going to be negative 3 times the quantity, x cubed minus 4 to the negative 1. All right, now to differentiate, I have a constant and I have a quantity to a power. What is this? What rule would I use? Good job. It's the chain rule. I'm going to use the chain rule. Go team. So, to differentiate this, I'm going to use the chain rule, derivative of the outside with the inside plugged in, times the derivative of the inside. So the outside, I have negative 3 on the outside, which is just a constant. I have the negative 1 exponent on the outside. So I'm going to bring that negative 1 exponent down, making this positive 3. I'm going to have a quantity, and then I'm going to finish the derivative of the outside. I have something to a power, so I use the power rule, which means I'm subtracting 1 from that power, which would make it negative 2. And then the next part of the chain rule will be with the inside plugged in. So I'm going to plug in the inside. Then I'm going to multiply by the derivative of the inside to finish the chain rule. Derivative of 4 is a constant, derivative of 0, x cubed. The derivative of that is going to be simply using the power rule, 3x squared. Now, you might be thinking, this does not look like x squared y squared. And you are correct, it does not yet, but it will. So, let's make it look like x squared y squared. First of all, let's simplify a bit. I have 3x squared and 3. I can make that 9x squared. I also have a quantity. I have a quantity to a negative exponent, so I'm just going to put that in the denominator. Right now, what was y? Y was negative 3 over x cubed minus 4. Could I make part of this y? Well, yeah, y is kind of contained in here, right? I have a 9, which is a multiple of 3, and I have an x cubed minus 4, which is that denominator. So I just need to factor things out and make it all work so that I can replace something with a y. But I also need x squared. But let's just worry about the y part for now and see how it goes. So if y is negative 3 times x cubed minus 4, or divided by x cubed minus 4, let's just write that. Negative 3 divided by x cubed minus 4. That's y. I want y squared, so let's square it. Now, if I needed to also have x squared to make that true, then at this point I'd pretty much be done, because this is y and that's x squared and y is squared, so I'd be done. But I'd be done double checking, that is. Is this equal to that? Let's see. Well, I already have x squared, which is part of my numerator. What about that 9? Okay, well, I'd have negative 3, and then it's squared, so that would be 9, so I'd have 9x squared. And then our denominator, x cubed minus 4, well, whenever I square the whole quantity, that's going to square the denominator too, so I'd have x cubed minus 4 quantity squared. And so then that's it. This is equal to x squared y squared, which we already said was equal to, let's move it down here, which is equal to the quantity xy squared. There's the end of example 1. Good job, everybody. Now let's try and do example number 2. So for this particular problem, the prompt is in the Google Slides that is accompanying this. This is an AP question. It would be a multiple choice, no calculator question. We're modeling the rate of change of something. The prompt specifically says something about the rate of change of the volume of the gas with respect to the pressure is proportional to the reciprocal of the square of the pressure. And this is a multiple choice question, and those options are all in the prompt. So this is Snickers. Stop it. This is a lot of problem, right? There's a lot going on in the words of this problem, right? It's a really wordy problem. But there's a few things to take away that'll help you determine which of these multiple choice options you want to pick. So we have the rate of change. First of all, rate of change means derivative. So rate of change is the derivative. Right? That's something we've been learning since September. That's what a derivative is, right? A derivative is an instantaneous rate of change, or it's the function that defines the rate of change of another function throughout its entire domain, or at least the domain upon which it's differentiable. We also have the definition of the derivative as the slope of a tangent line. There's also the limit definition of the derivative. Those are all the same thing. When we see rate of change, we think derivative. When we see any of those other things, we think derivative. So when we see rate of change, we think derivative. Next, we have the volume, rate of change of the volume of the gas. So we have volume as well. It's the rate of change of the volume, which means that's probably going to be our dependent variable, right? We have volume, rate of change of the volume. So that makes me think dV by d something. Rate of change of the volume of the gas. The volume is a property of the gas. With respect to the pressure, so I was right. I have the derivative, the rate of change, or the derivative, of the volume with respect to the pressure, P, we can call it P, is proportional. So now I have that is rate of change of the volume of the gas with respect to pressure is, which means now we're talking about what that rate of change of the volume of the gas with respect to the pressure is. So this is the rate of change of the volume of the gas with respect to the pressure. And then we're going to talk about what that is. So I'm going to set it equal to something, because when I set something equal to something else, I'm saying that this and that are the same thing. This is this. So I'm saying this is proportional. Proportion, I think a fraction, so I'm going to write a fraction, to the reciprocal, which means I'm thinking 1 over something, of the square, so I'm going to square something, and reciprocal of the square of means reciprocal of the square means I'm probably taking the reciprocal of something squared. And then it says is proportional to the reciprocal of the square of the pressure. So I have pressure. Now this is only part of the greater picture, right? All of the choices have a K somewhere, right? My K is going to be right here because I have some constant. It could be 1, it could be anything else. I just wanted to add in because we get interrupted a lot in my class. Might as well get interrupted when we're recording class. I'm at home at my parents' house over spring break here, and it looks like I might be staying here for a while to help take care of my grandparents and everything while we're doing online learning, so I'll be working from here probably. This is my basement at my parents' house. I had a whiteboard in high school, so I can now use it to teach high school. My sister's dog is at the vet right now, which is what my mom just called me about, which is why we got interrupted. He bit my hand, which you can kind of see the other day, because he was under the bed and I tried to pull him out and he bit me. So for once, the crazy snickerdoodle daisy is actually the well-behaved dog. So ha 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 to my sister. Take that. How about that, calculus? We have the rate of change of the volume of the gas with respect to the pressure is proportional to the reciprocal of the square of the pressure. Now, there's a tricky part still, right? We don't know whether K is supposed to be a positive or negative constant. There are still 2 options with this, all good, except one has K as a positive constant, one has K as a negative constant. So how do we know which one's which? Well, in the prompt, it says because volume decreases when pressure increases. And because of that, K does have to be a negative constant because this means that they have a negative relationship, right? They are directly related, they're proportionally related. In fact, the rate of change of volume with respect of the gas with respect to pressure is proportional to the reciprocal of the square of the pressure. But we also know, because of this relationship, K has to be a negative constant. Because whenever volume is decreasing, that means its derivative is negative. But pressure has to then be increasing to make this whole thing all coincide. All right, that is the end of example 2. Let's move on to example 3. Example 3 is still an AP question. It's also multiple choice. It's also no calculator. Now, this one's a little different. We've introduced some numbers. We don't have this K thing going on. We do know that there's the rate of change of weight with respect to time. Weight is directly proportional, it says, to this rate of change. So that means that weight is going to be right there. Now, whenever you think proportional, you think like a fraction, right? If this was all on one side, then I'd have to divide this over, so I'd have 1 over W. So there is a proportion going on there. But because it's direct, that means that we have equals just W. There has to be some kind of constant. It could just be 1. We don't know what it is, but it's K. There's always going to be a constant in problems like this. We do have an initial condition. We know that the rate of change of the weight is 5 when the weight is 200. We can use this to find K. So I have, in this particular problem, the rate of change of weight with respect to time is 5. That's going to be equal to this, right? So I have KW. But when that happens, W, the weight, becomes 200. So basically I have 5 equals 200K. I'm going to solve for K, so I divide by 200. So I have K equals 5 over 200, which reduces to 1 over 40. All right, there's the end of that example, because I can just plug that back in, and I have dW dt equals 1 over 40 W. And then I'm done. Example number 4 is going to be more challenging. It's also going to be AP multiple choice, no calculator. I doubt there's going to be a no calculator section on the AP exam this year. However, again, this was a problem from years past. Odds are we can still get some good practice out of it if nothing else. Most of these types of problems you probably won't need a calculator anyway. Some of them you might, but it's probably more for like decimal work or arithmetic work rather than the actual calculus part. So this particular problem asks for what value K, if any, is y equal to e to the 2x plus Ke to the negative 3x. So for what value of K, if any, is this y value, this y equation, a solution to the differential equation for y minus y double prime, the second derivative of y, equals 10e to the negative 3x. So what we're asking is, when does this y make this differential equation work? When is this a solution to that? For what value of K makes that true? So let's talk about it. Let's find the solution. Feel free to give it a try on your own. What we're doing is solving for K. If you do want to try it on your own, before you watch it all together, what we want to do is plug this y in here, plug in the second derivative of y, try and make it all work, and solve for K.